Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ASHRAAF bin ABID, and I'm going to explain briefly about our group project. So we are working on an intelligent system that can analyze the periodontal data to diagnose the levels of the periodontitis. And by incorporating these principles of automata theory, uh, we aim to develop and enhance the efficiency and also the accuracy of the periodontal diseases diagnosis system that already exists now, and also the treatment planning. This innovative approach also going to enable the periodontists to make more informed decisions based on a structured analysis of the patient data itself. Next, for our project objective, we are going to implement a deterministic finite automata to model and analyze the periodontal data. We also we also aim to develop the algorithms for an automata-based classifications of the periodontal data disease stages. We also want to evaluate the system's performance against existing diagnostic methods, and we're going to provide the recommendations for integrating the system into the current periodontal practices. For the literature review, uh, periodontal disease are very well known across all over the world. It's being widely spread globally, and it's very crucial to be paid attention to. However, the current diagnostics methods is relying very on the subjective assessments and also manually analyze the clinical data, which is going to be very challenging in terms of the accuracy and also the efficiency of the data itself. This research that we are working on project aims to improve this process by introducing the deterministic finite automata to the system as a novel computational tool to systematically process and also categorizing the periodontal data. Thereby, it's going to enhance the accuracy and also the efficiency of the collected diagnosis data and also the treatment itself.
Assalamu alaikum. We'll be talking about the implementation now. So what we're using here is a deterministic finite automata. Very straightforward, very easy. You can see there's no loop backs over here. Um, really, we have a few end states. You have the severe periodontitis for P2. We have periodontitis for P1 and gingivitis for G and N for healthy. So the idea is that once we have the generalized description of the patient's oral condition, we will be able to classify using this finite automata on what kind of condition the patient has. Now, for states for transitional states from Q0 to Q1, Q4, we can see the B and N, B for bloody, N for not bloody. And then we have plaque and clean, P and C, where you can see the transitions from Q1 and Q4. Now, this is also pretty straightforward. When there's plaque, we just denote a P, and when there's no plaque, we just denote it with a C. And then we have 0, 1, 2. These are grades for attachment loss. So the teeth and the gum, how close is the attachment? Is there any movement? Horizontal, vertical. We're going to have a generalized classification for that. 0 meaning there's no attachment loss, meaning no movement. 1 is attachment loss, typically within the bounds of 6 to 7 millimeters. And 2 is severe attachment loss, meaning the teeth moves around a lot. Now, let's take a look at some examples to see what's going on. So here is an example of a healthy patient. So starts off with N for not bloody. So it goes from Q0 to Q4. Then we have C for no sign of plaque, no plaque presence. That is Q4 to Q6. And so if there is no bleeding and no probing bleeding and no plaque that is present, we can say that even if there is attachment loss, even if there is a movement in the tooth, we can tell that it is not the result of any sort of gingivitis or periodontitis. We can say it is a healthy, relatively healthy patient. So it ends up at the N node. Then let's take a look at a patient with severe periodontitis. So we have bleeding on probing. So it starts with B, Q0 to Q1. Then we have plaque. We see there's plaque in the patient's mouth, and so it goes from Q1 to Q2. And then we see that there's a lot of movement in the teeth, horizontal and vertical. So we put the grade as 2. And so it ends up in the P2 final state, which is the severe periodontitis state. Now, gingivitis is a little different. So gingivitis is defined where, you know, there is bleeding on probing, and there is no plaque. Plaque doesn't really play plaque and doesn't really play a big deal in gingivitis. But basically, it is if there's bleeding when probing, but there is very little attachment loss, then it is most likely gingivitis. So we can see from if there's bleeding, we go to Q0 to Q1, then we don't see any plaque, so it goes from Q1 to Q3, and then we see very little attachment loss, so Q3 to G, which is gingivitis. That are some examples of this implementation of deterministic finite automata in the field of periodontology. Thank you very much for listening.